So students, now we'll start the practical number 11. This is the experiment. Again, it is to be performed on the alternator, and aim of this experiment is to perform the direct loading test on given three-phase alternator. By performing the direct loading test, you have to determine the voltage regulation for various power factor loads. So we will be using three types of loads: resistive load, inductive load and capacitive load. And for these three different loads, we want to calculate the voltage regulation. The practical significance of this experiment is that so many times we have to determine the voltage regulation of alternator to understand the performance and efficient working of the alternator, because these alternators are widely used in the generating stations and they are facing a wide variation in the nature of the load. Most of the time industrial loads are inductive type of loads, and some of the loads are resistive types of load, and sometimes we will be having some capacitive load. So direct loading test gives us a possibility to analyze the behavior of the alternator for all these three types of loads, which will be having unity power factor, lagging power factor and leading power factor. So when we are starting this experiment, what is the connection that we'll see first? So the connections of this experiment are similar to the connections of the previous experiment, that is open circuit test and the short circuit test of the alternate. So again we are using motor as a prime mover, and with this prime mover we are starting this alternator. Alternator and motor are mechanically coupled to each other. So input mechanical power which will be supplied by the motor will be converted into electrical energy. In this case now we are going to connect the variable load on the output of the alternator. So this is what a three-phase variable balance load. So we are connecting all the three types of load: star connected, resistive load, then inductive load and then capacitive load, and we will be conducting three different setups for three types of load variation. So if we consider the connections for the motor, then the connections for the field winding of the alternator, they are similar to previous setup. Only the connections which are new to you are now how to connect this load. So we'll trace the previous connections as it is, and then we'll see how the load is to be connected. So starting from the supply terminal, supply positive will go to the L terminal of the 3-point starter. L terminal of 3-point starter. So supply positive goes to L terminal of 3-point starter. Then A point of the 3-point starter. A point of the 3-point starter. This A point, it will go to A1. A point will go to A1. Then F point will go to F1. F will be connected to F1. F will be connected to F1. Then where F2 goes? F2 goes to rheostat. F2 goes to rheostat. So we are connected to the fixed terminal of the rheostat, and then another terminal of the rheostat, that is variable terminal, it will be connected to A2. It will be connected to A2, and this A2 will again go to the negative of the supply. A2 will go to negative of the supply. That means variable terminal of the rheostat, variable terminal of the rheostat and A2, they are to be connected to the negative terminal. They are to be connected to negative terminal. So what we have started, starting from the starter, we come to armature A terminal, field F terminal. Then F2 goes to rheostat fixed terminal and rheostat variable terminal A2. Togetherly they go to negative side. So that was the connection for DC shunt motor. Now as far as field winding is considered, as it is, we are using potential divider. It goes to rheostat. Supply positive goes to rheostat fixed terminal on one side. On the other side, supply negative goes to other side fixed terminal of the rheostat. So full voltage gets connected across the two fixed terminals of the rheostat, and then from the variable terminal of the rheostat. Then from the variable terminal of the rheostat, we will connect it to ammeter positive. This will be a DC ammeter which will measure the current through the field winding of the alternator. Second terminal of the ammeter, it will go to F1. It will go to F1, that is the field winding of the alternator, and F2 will go to negative of the rheostat. F2 will be again connected to negative of the rheostat. So that completes the connections for the field winding. Now this much connection we already done in the last experiment. What are the connections which we want to make are now the connections for the load. Connections for the load. So for that again, you will be having three terminals, stator terminals R, Y and B. So from R terminal we will be connecting now AC ammeter. From R terminal we will be connecting AC ammeter which will measure load current. So R terminal will be connected to common of the ammeter. Second terminal of the ammeter should go to the R phase of the starter load. So now before connecting this, we will see how the load is used. You will see this is a three-phase load. This is a three-phase load. R phase, Y phase and B phase. These are the three starting terminals R1, Y1 and B1. We want to make a star connection. So we are connecting R2 to Y2. You will see this wire. So through this wire we have connected R2 to Y2, then Y2 to B2. That forms the neutral of the starter, and then this neutral, it will be connected to neutral of the alternate. This neutral will be connected to neutral of the alternate. Now what we are left was the ammeter's connection. From the R phase we are connected to ammeter common, and now second range terminal 5 ampere range we are using, it will be connected to R1. Y1 will be connected to Y, B1 will be connected to B. So stator output Y gets connected to Y1 of the load and B gets connected to B1 of the load. Okay. So you can see here that there are three phases of the load, and we have to connect the balanced load, means at a time equal load should be on in R phase, Y phase and B phase. Now to start the experiment, we have to connect the supply to the motor, then operate the 3-point starter. So motor will be started, then make the alternator on. First you have to take the speed, adjust the speed to 1500 rpm. For adjustment of the speed, we will be using the flux control method. By adjusting value of this rheostat variable terminal, we will be adjusting the speed of the motor, and that will be adjusted to the rated value of 1500 rpm. And then we will see how to make the load variation. So students, now with the connected resistive load, we will make the motor on. So for that, first put on the main switch. After that, rotate the handle of the 3-point starter. Initially it was off, now it will be on. So motor will be started. We have already adjusted speed to 1500 rpm, and now we will start the alternator. So for that, first put on the exciter switch on and then increase the excitation. On increasing the excitation, till the time we get the voltage to the rated value, but to be on the safe side, we are increasing the excitation current till the time alternator shows voltage of 350 volts. Alternator shows voltage of 350 volts. by increasing the excitation of the rheostat, we have adjusted the alternator output to 351. This is our first reading with the no load. So we'll note down the reading. For resistive load, IL equal to 0 and voltage is 351. Now we'll make the load on. The load current, AC ammeter will be showing the load current. It is 1.4 and voltage is 334.7. Again increase the load. Current will be increasing 2.6 ampere. Voltage is 288. One more load step, 3.45 current and voltage 258.8. And then the last reading, current is 4.2 and the voltage is 233 volt. So that was the last load. Now we'll make the load off. Then alternator excitation set to 0. After that, we will be taking the readings for inductive load. So, after making all the connections, now we will make the machines on. First, we will make the motor on. So, for that, put on the main supply switch, then rotate the starter handle to make the machine change the position of the machine from off position to on position. After that, winding of the exciter and then increase the excitation current. For that you have to change the handle position so that potential output voltage will increase. Then we will see the current, excitation current. Increase the current till the time it shows the voltage of 350. So how much is the current? Actually we have connected 2 ampere range, so current is 0.7 ampere. Current is 0.7 ampere and the output voltage is 351. Field excitation current is 0.7 ampere and the output voltage is 350. So this is your first reading. Load is off. We are connecting the experiment for inductive load. We are making the ready for inductive load. So IL is 0. IL is 0. IL is 0 and the current voltage is 351. Voltage is 351. Okay. After that we will make the load on. Making the load on, load current increases. Current is near about 0.8 ampere. 0.8 ampere and voltage is 329.5. 329.5. Again one group of switches increase. Current is 1.65 and voltage is 306.8. Then next load, current is 2.25. 2.25. Voltage is 284. 284. And for the last reading, current is 2.75. 2.75. And voltage is 261. 261. So we have taken 5 readings. Now we will make the load off. First we will make all the load off. Then alternator off. Make the excitation 0. Alternator excitation 0. Touch to the starter handle. So we have completed two setup with resistive load, unity power factor, inductive load, lagging power factor, and now we are connecting capacitive load which will be having leading power factor. Again 3-phase load with a star connection, and with this load we will start the machines. So first make the motor main supply on, then operate the starter so that motor will accelerate and reach to the rated speed. We have kept rheostat fixed position, so speed is 1500 rpm. Now alternator side, excitation supply on, increase the excitation, increase the excitation, till the time it shows the voltage about 350 volts. 350 volts. Excitation voltage, it is slightly increased, so reduce it, and it is now adjusted to 350 volts. Excitation current is 7 ampere, upper end 0.7 ampere. That we are taking for one time. We are taking it for one time, and now with the inductive load we have completed, we will go for third observation table, capacitive load. So for the first reading, load current 0, and voltage is 350. 349.7. 349.7 approximately equal to 350, and now we will make the load on. First load. So observe the current. Again it is 0.8 ampere. 0.8 ampere, and the voltage is, for capacitive load you will see the total different behavior. After increasing load, output voltage will increase. So it is 363.4. 363.4. Now we will make the load on. So current is 1.6 and voltage is 379.9. Again increase the load. How much is the current? 2.45. 2.45. Voltage is 387. 387. Last reading will take for current equal to 3.2. Current equal to 3.2. So current will increase, simultaneously voltage is also increased. 392.4. So thus you see it is increasing the voltage, so it gives a positive regulation. So we have taken the reading for inductive load, resistive calculate the regulation. It is simple procedure, so I am not going to show the actual calculation. I will just explain. So we have to do three different sample calculation, one for resistive load, then for inductive load, and then for capacitive load. Formula is same, E0 minus V upon V, that is up regulation, or E0 minus V upon E0, that is down regulation. So you have to calculate up regulation and down regulation for each stage. You take only one reading, and for one reading calculate up and down regulation. For example, you can take second reading, and with the second reading you have to do the calculation for resistive load, for inductive load and capacitive load. Put E0 as 350 and V will be suppose here 363.4. So if you see this calculation, it will be 350 minus 363.4 divided by 350 into 100. So you get all the regulations, summarize it in the result. Also you have to complete the regulation calculation for each column, and then you have to plot the three graphs showing regulations. Regulation for resistive load, that is unity power factor, regulation for inductive load, that is lagging power factor, and regulation for capacitive load, that is leading power factor. So you will show the graph for terminal voltage and the load. So this graph you have to plot, and you have to calculate the three regulations. So that will complete the experiment. Write down the question answers, and you will stop the practical here.